Because on that side of the piecewise function is just a polynomial. It's all act like. So plug the 1 in, you get what? 4? 4. On the left-hand side, it acts like 2x. So the limit as x approaches 1 from the left of this function will always be acting like 2x to the left of 1, right? To the left of 1, it's always 2x. So you're writing down a line here. You're writing a quadratic here, you're writing a line here. This is going to be a 2. Okay? So does the limit exist? No. The left and right limits are not the same. So therefore, this is a D and E. So we've just shown it's not continuous at x equals 1, because the limit does not even exist there. But you had to break it into these two parts to even talk about the limit itself, right? You know what I'm saying? You know what I'm saying? Yeah. All right. So what's going on with this function? What's x squared plus 3x look like? Can you draw it? What's x squared plus 3x look like? It has a 0 at 0, it has a 0 at where? Negative 3? 1, 2, 3, you've got zeros there. Does it open up or down? Up, right? Leading coefficient is positive. So we'll just make some pretense here. We'll say it looks like this. That's beautiful. But now this thing's only good as it's greater than or equal to 1. Okay? Say again? It crosses the x-axis at negative 3 and 0. This thing does, right? You see that or not? Because it makes it 0. You would just factor it. Oh, okay. Yeah, sorry. So, yeah. Okay, so you have a quadratic from negative and, sorry, greater than or equal to 1. So greater than or equal to 1 is only this part of the picture. So, and at 1, what is it, 4? 5. 1, 2, 3, 4. So you'd be here, and that is the picture you have, and you don't have any of this, right? That was just to draw the part we needed, right? So there's the quadratic portion to the right and equal to 1. And you have this other thing called 2x, wherever it's less than 1. So 2x looks like what? It goes to the origin, and it has what, a slope of 2, so it goes up 2 in the right one. So like there, there's a hole. And it goes down like that. So there's your quadratic sort of scooping away like that, right? So there's your quadratic, and then it suddenly jumps to this, and it goes like that. And that's why there's no limit there, right? The jump discontinuity. So therefore, you've now proven that this piecewise defined function, not based on the picture, just want you to know what it looks like, is not continuous at 1. So now the question is, where is it continuous? You've shown it one place it's not. That doesn't mean it is everywhere else necessarily, right? You know one place it's not. So now how do you know where it is? That's probably the next question they're going to ask. Oh, that's not what they asked. Is f continuous? Oh, geez, Louise. You tell me, where's it continuous? Give me an interval of continuity now. Interval of continuity. Jan, what do you say?
Negative 1.
Oh, okay.
Right. To the left of, well, start with the right. To the right of 1, and even including 1, it acts like a polynomial. Where's a polynomial continuous? Everywhere it's defined. Since it's defined for greater than 1, so greater than 1 here to infinity is true. It's continuous there. The other one, 2x. To the left of 1, 2x is a polynomial. It's defined for any value less than 1. So any value less than 1 is going to be continuous there because it's a polynomial. Right? So that's the question. That's a bigger question. When we are talking about continuity in general, this is a more subtle question, and I'm glad you asked it. When you're talking about continuity in general, use what do you call them? Parentheses, not brackets. Continuity as a whole, use parentheses. Okay?
Don't you need brackets when if there was a hole to?
Let's draw the picture again. I'll tell you why I'm not using a bracket. So the picture was what? Something here, kind of like that, and then something here, kind of like that. That's good enough for our purposes, okay? So the dot is filled in here. So the function is defined at 1. It has a value called 4. It does not make it continuous at 4, right? Remember that continuous at 4, sorry, 1. Sorry. This is making continuous with the x value of 1, even though it has a height of 4. It has a value there. We just showed a second ago that since the limit is not the same from left and right, then the definition of continuity demands that it does not be continuous at 1. Okay? So when I'm asking about overall continuity, I cannot include the 1 in this case, even though it's defined there. We just showed by the definition it's not continuous at 1. So I'm using a parentheses, even though it's defined there. Okay. Is that okay? So far? There's a more subtle idea of continuous from the left and continuous from the right. Right? Let's just say that over very quickly. That's what the question actually asks. So now, where is this? Is f of x continuous from the right at x equals 1? And it's going to ask the same question. Is it continuous from the left at x equals 1? Okay. So all you're looking at is, as this thing travels down the curve, right? This is from the right, correct? To the right of 1, traveling towards 1. As we travel down here, does it become its function value? The answer is yes. Okay? So therefore, continuous from the right, check. It is continuous from the right at 1. Okay? And you'll notice that's because the right-hand limit, which is 4, is the same as the function value at 1. The right-hand limit is the same as the function value. Just like a second ago for regular continuity, limit, same as function value. So when we're talking about right-hand continuity, right-hand limit, same as function value. Okay? Everybody agrees the function value is 4, right? When you plug in 1 in here, where does it go? It goes in this one. It says equal to 1. So you plug in 1 here, you get 4. So the right-hand limit is the same as the function value, so therefore it's called continuous from the right. It has right-hand continuity. All right? Well, left-hand continuity. The answer is no. As you travel up the 2x curve, it is not heading towards its own function value. It's heading towards a hole. Okay? So therefore, even though the limit is defined to be 2, that is not the same as the function value. The function value, f at 1, is 4. Since these are not the same, it is not left-hand continuous. It's not continuous from the left. All right? Only continuous from the right at that location. Roger?
When we take these